So we have completed till like we have started structural isomerism, right? So under that structural isomerism, okay, structural isomerism. So in this structural isomerism, basically we have completed only the ionization isomerism, like the first type of isomerism, which is ionization isomerism, right? Fine. Ionization isomerism. Under this, we have seen that with the sulfate and with the bromide, we have seen, right, the example which already we have discussed, like it has came in IIT JAM. So based on that, this example also helping us, okay, to understand. So let me see the example. It is like we were having cobalt with NH3, that is 5 times, and Br, and we have sulfate ion, which is if I react, okay, with what we can say excess like barium sulfate. If I use barium ion, we will get cobalt, NH3 5, Br, and then it will be like +2 as well as barium sulfate, right? Likewise, if we take another isomer of these, ionization isomerism of these, that will be cobalt, NH3 5 times, SO4, and in this, if I put Br at outside and if I treat this with excess of AgNO3, okay, AgNO3, so you could find this like you will have cobalt, NH3 5 times, SO4, and here it will be plus, and AgBr as a precipitate, right? So it means that if these two are isomers, okay, let me tell you, these two are isomer. We have seen these two are belongs for ionization isomerism. Okay, see, in one form this is your ionization form, and in the second case this is your ionization form, right? In one case it is in +2 state, another one it is in +1, right? Or you can say that in one case the sulfate ion went away, like it will act as a counter ion, and in the second case bromide as a counter ion, right? So with this we have, like, just I'm giving a recall. I know we have completed this, okay, in the previous class, so just I'm giving a recall for the things, like, so the smooth transition for the next type of isomerism, structural isomerism. So for that I'm just giving you the information regarding this. So these two are ionization isomerism. The A and B, we call it ionization isomerism. And how to find it out? We have to react it with barium salt and like BaCl2, and then with excess AgNO3. Suppose if your compound is reacting with excess of AgNO3, it means you have this form of ionization isomerism. If it is reacting with barium chloride, then this sort of ionization isomerism is present, right? Okay, because this one will not react with barium sulfate. This will not react with barium 2 plus, right? And this will not react with your AgNO3. Okay, this will not react with AgNO3. So like that, we have to find it out. Now, next type of isomerism, we can continue it. That is nothing but solvate isomerism or hydration isomerism, right? Okay, solvate isomerism, or we can call it hydrate or hydration isomerism. Fine. So in this case, generally water exchange will takes place. Okay, like water exchange means at like initial state, you can say that water will be acting as a primary valency, and the second in the second case, you will find that water will act as a secondary valency, right? So primary valency and secondary valency. Okay, means it will come out from the coordination sphere. Sometimes it will be inside the coordination sphere. So that type of differences we could find it out for this hydration isomerism. For example, if we take cobalt 6H2O and 3Cl, okay, if we are taking this example, and if we are reacting with AgNO3, if I reacting with AgNO3, okay, excess of AgNO3, if you are getting 3AgCl, then you will have some sort of complex. If you are having 2AgCl, then you will have some sort of complex, and then you should have AgCl. Okay, and then at last you will not have any AgCl. Okay, means it will be like as initial it was, without any ion, like no ion will form. So in the first case, if you are getting 3AgCl, it means your complex will be like this cobalt, and then you will have H2O, or we are calling it hexa aqua, right? As per IUPAC nomenclature, water we used to call it here aqua, right? So fine. So in this case, it will be 3 plus. Okay. Another type of isomerism, like if we are getting 2 AgCl, it means only 2 chloride present at a counter state. Okay. So it will be cobalt, H2O 5 times, and Cl. This will be 2 plus. And then next you will be cobalt, H2O 4 times, Cl2 and plus. Like this complex you will get it. Now, these are all hydration isomerism. Okay, these are all hydration isomerism. How? I'm just telling you, hydration isomerism. Okay, see, only water is coming outside. Okay, see, we have taken the initial complex this, right? So now if we have 5 water, suppose if we have 5 water, so another water, where it will went? It will be on the outside. If I write the complex, then only you will come to know. Okay, in this case, you have 4 water molecule over here. So where is those 2 water molecule, right? So for that, I have to draw the complete complex, so you will understand. So first one is fine. So I'm just writing the first one, very first one. So what I'll do, I'll just mark it. It is A, this is B, and this is C. So one by one, let me draw first A. So A molecule will be your CO, and then H2O, and then Cl3, right? Then what is the B? If I draw the B, this molecule, it will be CO. Now the isomerism will start. H2O 5 times Cl. See, chlorine went inside, at the same time one water will come out. You've seen this type of molecule, right? When you see the washing soda, there it will be 10H2O, right? Dot 10H2O. So likewise, this is hydrated isomers, right? Now, if I want to write the C cobalt, and I have to write water 4 times 2 chlorine. So if 2 chlorine went inside, then 2 water molecule will come out, right? So Cl and dot 2 aqua. So these are the complex, right? So what is happening generally? See, all water molecule are inside. Now one chlorine went inside and one water came outside. Likewise, 2 chlorine went inside, 2 water molecule came outside. So this is a hydration isomerism, or solvated isomerism we call it. Understood? So this type of isomerism you will see. There are more examples that we will discuss when it will come in examination. Okay, like when actually you will prepare for like when you will be ready for your examination. Before that, I will try to launch a test series, so you will come to know the different kind of questions. Okay, so that time you will find more examples, right? Now next, this is the second type, solvated. Now next is third one, linkage. And now you have to understand, before linkage, you should understand what is amphoteric or ambidentate. Okay, ambidentate ligand. Okay, what is ambidentate ligand? That you have to understand. Okay, so to understand linkage isomerism in proper way. Okay, so what is linkage isomer? So in this linkage isomer, generally it will form. It is the name itself suggesting that it is something with link, something with connection, right? How it is connecting with others, it is depending on that. Correct. So how to find this linkage isomerism or linkage isomer? One second. Okay. So for this you should know ambidentate ligand. I think I have discussed this in your previous class. What is ambidentate ligand? Ambidentate ligand means the ligand which is having more than one donor atom. Okay, but they can donate at a time only from single site, right? So these we call ambidentate ligand. Understood? So these ambidentate ligand will have uh, two donor atom. Okay, and those two different donor atom, but they can donate at a time. They can donate only from one site or one atom. Okay, so for example, examples are NO2, right? So NO2 and means NO2 means nitrogen is donating, and ONO you can write. So here NO2 is donating through oxygen, right? Likewise, we will have CN, like from carbon it is donating, and we can have NC from nitrogen side it is donating, right? So likewise, we will have some other examples also, like SCN from nitrogen side it is donating, and NCS from sulfur side it is donating. Okay, likewise, we will have many. Okay, these all are bidentate, like not bidentate, these are ambidentate. See, there is a difference. Like it came out bidentate, so I should be tell you about the bidentate. What is the difference between bidentate and ambidentate? See, ambidentate means we have more than one donor atom. Like we have two donor atom, but at a time only one donor atom can donate. But bidentate ligand, both the donor atom will donate. Okay, and always remember that if bidentate ligand is present, so minimum chelation, it is required five-membered ring, right? So if bidentate ligand is donating, it will form five-membered ring. Now, if you are try to donate from this particular molecule, like if you want, like for nitro, if you want to donate from oxygen also as well as nitrogen, it won't form pentavalent, right? It won't form five-membered ring. So that's why this is not possible. Okay. So either it can donate through nitrogen or it can donate through oxygen. So that is ambidentate ligand, right? So now how it is helping in linkage isomerism, that will come to know. Like the linkage isomerism here, it says that if it is connecting through nitrogen, it will be some other isomers. If it is connecting through oxygen, then it will be different isomers, but molecular formula will be same, because overall nitro functional group is attached. But the thing is, sometimes it will be connecting through nitrogen, sometimes it will connecting through oxygen. That's why it is linkage isomerism, right? So that you have to find. And now why it is so much important? Because when you will learn the symbiosis effect, okay, so in that time the symbiosis effect will help you out. Actually, we have to see here only. So linkage isomerism will be, I think, two classes it will require today, and one more class it is required to complete the symbiosis effect. So that symbiosis effect, you have to see that hard and soft interaction, right? What is symbiosis? There you will see hard interaction, or soft, okay, soft interaction. Okay, that will be the stable product. Don't worry, I'll teach you everything. You will get to know. Okay, so now in this case, first of all, we will try to understand the different type of linkage isomerism, and then we will move towards the symbiosis effect. Okay, so that you have to know, because if you want to solve more number of questions, you should know the concept. Okay, what is symbiosis? Now, for example, you have cobalt, NH3 thrice, NO2. Okay, then sorry, it will be 5 times. Okay, then 2 plus. 2 plus means outside we can take Cl2 also, if you don't want to write 2 plus. Then second one will be cobalt. Okay, and along with the cobalt, it will be NH3 5 times ONO. Okay, understood. This case, in the first case, it is connecting through nitrogen. Okay, it will be NO2. It is connecting through this nitrogen. And the second case, it will be connecting through ONO. Okay, so cobalt is connecting through ONO. And in the first case, cobalt is connecting with NO2. So cobalt is connecting with nitrogen. Here, cobalt is connecting with oxygen. Got it? So here also it will have 2 plus. Fine. Now, next example, we will have cobalt NH3 5 times NCS. It is connecting through nitrogen. So you will have +2, and you will have cobalt NH3 5 times SCN. So connecting through sulfur. So these are all linkage isomerism. So only if they're asking for linkage isomerism, here it is completing. Okay, but see, we have to see how many isomerism it will increase, because directly we will come in that place where we were doing geometrical isomerism and your optical isomerism, and you have seen there I have not chosen any type of this ambidentate ligand, right? Because there is a time, like whenever the time comes, I will choose that type of example. That's why I have not chosen in that that time. Okay, when I was discussing the geometrical and optical isomerism, right? So now you have to focus. If you have given with the example where you have two geometrical isomerism, then two linkage isomerism will also continue. Like, see, if you have connecting with nitro, it will be ONO. Now, if cis form is having nitro, then their cis form, it can connect with NO2 and ONO. Now, your trans form is having nitro, the trans form will have NO2 and ONO. So, two more isomers is getting added of there. For example, I'm just taking an example, and then I'll give you. So, for example, what I want to say is, suppose you have a complex with platinum NH3 twice and then NCS twice. So this is a type of Ma2B2, right? And this is a square planar complex. Okay, so square planar complex means optical isomerism won't be there. Okay, as I told you, square planar complex will not have optical isomerism, they will have only geometrical isomerism. Likewise, tetrahedral molecule will have only optical isomerism, they will not have geometrical isomerism, right? Now, in this case, if it is Ma2B2 type, means we will have a cis form and we will have a trans form. So we know that the geometrical isomerism we were having two, right? Cis and trans form. Understood? Likewise, in this case, we will have two linkage isomerism also, right? Two linkage isomer Li. Okay, how many will be there? Two. So suppose we have cis. Let me draw. Suppose like cis and trans, I'm drawing platinum. I hope you have understood, but let me draw. And like first time I'm giving you, so let me draw. Then here NCS, right? So this will be your cis, because as I told you, cis will have always 90-degree bond angle. If both the similar ligands are present and they are forming 90-degree bond angle, so that will be cis, right? Now, what is the transform of this? The transform will be platinum. Here one NH3 will be there. Second NH3, you just put it over here. Now, here we have NCS and second one will be having NCS, right? So this is your transform and this is cis form. Now, this complete your geometrical isomerism, right? So geometrical isomerism, we have two. Now see, what about linkage isomerism? Now for this cis, we have another form. Okay, we will have another form. What is that? We have the linkage one. So both NH3 will be there. Now this side, what we can take it as C and N. This side we can take as C and N, right? So this will be also cis. Okay, this is also cis, but these two are linkage. Okay, the linkage isomerism is between these two. These two are linkage isomerism, right? But these two are cis trans, right? So likewise, we will have another one here in the trans form. Platinum, here we will have NH3, here we will have NH3. See, only this will show with your ambidentate ligand. If you have ambidentate ligand, then only this type of isomerism it will show. This is also trans. Now, you just see here these two belongs to cis and trans. Here these two belongs to cis and trans. Now, these two belongs to linkage isomerism. These two belongs to linkage isomerism. These two trans and trans. I hope you understood, right? What I want to say. Now, total, how many linkage are there? So, linkage isomerism, Li, is 2. So, overall, 4 isomers. Like, total stereoisomers is 4. Okay, likewise, total stereoisomers equal to 4. 2 linkage and 2 geometrical. So, now, if you don't know the linkage isomerism, then what you will do for this type of molecule, you will say that, okay, it is Ma2B2 type. But this is a special case of Ma2B2 type, right? If it is a normal monodentate ligand, if it is not having ambidentate ligand, then it is fine that it is having two geometrical isomerism. Okay, it won't have linkage isomerism. But in this case, in this situation, you are having a ambidentate ligand. So that's why linkage isomerism is connecting. So whatever isomerism we have discussed there, okay, like from starting from Ma6, then Ma5B, then Ma4B2, then Ma3B3, okay, all those example you have to put one linkage isomer, like ambidentate ligand, and you have to see how many isomerism is getting or increasing or decreasing. That you can take as a homework, right? Like what you have to put, you have to put either CN or NC. You have to put either NCS. Okay, maybe some network issue. Okay, so again, you have joined. So we'll see. So these are the things which I was explaining you. So in this, what you have to learn, if I say out of this four molecule, there are two molecules which are stable and there are two molecules which are not that much stable. So how to find it out? For that, you have to find it the soft interaction and hard interaction, right? So always remember the nitrogen are harder, sulfur is softer, right? So see, this nitrogen is interacting with nitrogen. Here nitrogen is interacting, nitrogen is interacting with nitrogen, nitrogen is interacting with nitrogen. Opposite side it should have, right? So these will be more stable. Now here sulfur is interacting with nitrogen, here sulfur is interacting with nitrogen. So this is not that much stable, right? Now one more thing, okay, here one more thing, if you what's like if I take an example with the color, you will come to know. Suppose I'm taking another example here. Suppose you have NH3 5 times connecting with cobalt, and this side if it is connecting with O and O. So this is also a form of writing coordination compound. So overall it is having 6 ligand, 5 NH3 and 1 NO2, right? So here one molecule, and second of this linkage isomerism is 5 cobalt, and it will connect with NO2 Cl2, right? So both are looking same, the molecular formula wise, okay, the atom, everything is perfectly fine, same, but the color it will show red color and it will show yellow color. Okay, so you just see here what we could find it out here, the bond strength or okay, the bond strength will be less. That's why it is showing red color, right? Understood? Or we can say that lambda max, whatever the lambda max we will get, that will be high, because red color lambda max is high. So that's why it will show lambda max is high. Like this question, it will generate like out of these type of isomers, like all these isomers in the linkage isomers, which one will show a stronger bond length, okay, stronger bond strength, and which one will have weaker bond strength. See, bond strength less or weaker bond strength, it means that cobalt and oxygen, the bond length is more, right? The more bond length, it will be more weaker. The less the bond length, if bond length distance is lesser, then it will be a stronger bond, right? So there lambda max will be low. That's why the yellow color is having lambda max low. So if you see, I just take yellow color over here. So this bond, we know that it is a strong bond, fine. And here lambda max will be less. Okay, understood? So likewise, we are differentiating the things. Okay, and strong bond will be thermodynamically stable. That is not required over here. So now what we will do, we'll just see little bit of HSBA principle, where it's like strong and weak interaction they have shown. So there only we will see the symbiosis effect. Okay, so what is symbiosis effect? That you should know over here only, because that is directly involving with linkage isomerism. Okay, so if you see the symbiosis effect, okay, before symbiosis effect, what I'll give, because I think we have to see here. Uh, it is very, as I told you, 2 class it is required. So what we will see the symbiosis effect. So this is your metal, this is ligand, this is ligand. Okay, so this is if I say that this is your soft Lewis base and this is soft Lewis base, then this molecule will be stable one, right? Likewise, if you have metal connecting with ligand, if this is hard Lewis base and this is hard Lewis base, then this is also a stable, right? This is also a stable one. This is also a stable one. But if you have like interaction of L, M and L, so what I'll do, soft L and hard L prime, okay? So if you have L connected with L prime, it means you have soft Lewis base is connecting with hard Lewis base, this will be unstable. Means maximum reaction is doing by this type of situation, okay? So let me put in a example, okay? So suppose you have a molecule, cobalt, okay, nh3 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 and NO2, right? This is a molecule of Ma5B. You just see 5 1 2 3 4 5 ammonia and 1 nitro, so Ma5B type of molecule, right? And always remember that the nitrogen, okay, nitrogen is a hard Lewis base attachment, and your sulfur or oxygen is a soft Lewis attachment, right? So now the another type of molecule we can draw it, because if you see in the geometry Ma5B type of molecule, we have seen that we were having zero geometrical isomerism and zero like optical isomerism. Total only one isomerism because of the self isomerism, right? But you just see Ma5B, if we are taking nitro, we can form one more complex over here with NH3, 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 NH3 with the same O and O, right? So these two are like, we can't say it is a cis or trans, but we can say that these two are linkage isomerism. Like this is also Ma5B. Now you just see problem. Okay. Now continuing this. So you just see this is a hard, and this side, this ammonia is connecting with nitrogen. This is also hard. So we can say that this is a type of metal with hard Lewis base and with hard Lewis base, right? So this will be stable, quite stable. Now, if you say here, this is your hard Lewis base, but this is oxygen. That is okay. So this is your soft Lewis base. Now you can see here metal connecting with soft Lewis base and hard Lewis base. As I told you, hard and soft will be stable, but hard and soft, we have seen over here, this is not stable, unstable, right? You just see unstable. So here they will give a example. Okay, so this is less stable. So the question how it will arise, it will be like two molecules they will give, and with this like two isomer they will give, and they'll ask that which one is more stable, right? So the more stable one is this. Whenever it is connecting with nitrogen, it will be more stable, and whenever it is connecting with oxygen, this will be less stable. Understood? Okay. So today this much only. Next we will see in the next class. Okay. So thank you.